Hey guys, welcome to the very first video of our econometric course for 500 level Agric Economics and Extension students. Today we are starting with the introduction, econometrics. So what exactly is econometrics? The word itself, econometrics, literally means economic measurement. In simple terms, econometrics is just a fancy way of saying we use numbers and data to measure what is happening in the economy. Another definition of econometrics is it is the application of statistical methods to the study of economic data and problems. That means we don't just guess. We use statistics to study the real economic data. Econometrics is a branch of economics concerned with the use of mathematical methods, especially in describing economic system. So we bring in or introduce mathematics to describe how things like prices, yield, and cost actually behave. And the best definition of econometrics for you guys is this: econometrics is a branch of science concerned with the integration of economics, mathematics, and statistics for the purpose of measuring and testing economic phenomena and relationships. Now let me give you a perfect example from what you already know. Irrigated rice farming here in Nigeria. Suppose we want to know, does applying more fertilizer really increase rice yield on irrigated farms in Adamawa State? Does applying more fertilizer really increase rice yield on irrigated farms in Adamawa State? Or how much does an extra hour of irrigation increase yield per hectare? That is, increase the rice yield per hectare. These are real questions farmers and government ask every season. Econometrics helps us collect data from many farms and then use mathematics and statistics and give an exact answer, not just maybe or I think so. And that's why the course is powerful. Econometrics is powerful for you guys as future Agric Economics and Extension officers. Three basic components of econometrics. Econometrics has three major components. Econometrics has only three building blocks. That is why it looks complex, but it's actually very simple once you see them. We have economics, mathematical analysis, and statistical analysis. These are the three basic building blocks of econometrics: economics, mathematical analysis, and statistical analysis. Look at the diagram I drew for you here. You can see economics at the top. From economics we get theories. For example, the theory that more fertilizers increase rice yield up to a point. And then from theory we move to mathematics. Then we now convert or turn this theory into an equation. An equation is something like y is equal to beta naught plus β₁ x1 plus β2 x2 plus what? Error term. Now this is called dependent variable. Dependent variable is the variable that we want to explain or what you want to predict, while this one is called intercept or constant. Intercept or constant. This is the starting point. Beta naught is the starting point or the baseline. For example, beta naught might be 800 kilogram per hectare. 800 kilogram per hectare, meaning that even with no extra fertilizer or extra hours of irrigation, the best yield, best spell at BSE, BASE, the best yield or the starting yield from good soil and rain-fed part is put around 800 kilograms. So that is what is meant by what? Beta. Is that understood? Good. Now, after beta naught, in this equation we have β₁. This β₁ is slope coefficient for the first variable x1, right? And in this case, the variable x1 stands for fertilizer, right? So this β₁ is slope coefficient for variable x1, which is fertilizer, and it means β₁ measures the amount by which the dependent variable changes, y changes as a result of change or increase in the independent variable. β₁ measures the amount by which the dependent variable changes as a result of change in the independent variable. β₁ is just like change in y all over change in x, which is dy dx is our β₁. β₁ is amount of changes caused by the independent variable on the dependent variable. β₁ amount of changes caused by the independent variable on the dependent variable. Then β₂, slope coefficient for variable x2, which is in this case is extra hour of irrigation, and it is the amount of changes caused by the extra hour of irrigation on yield, which is the dependent variable. Now, β₁ x1 effects coming from variable x1, which is fertilizer. Effects coming from fertilizer. Then β₂ x2 is effects coming from irrigation. Effects coming from irrigation. Now, the last one, which is error term or disturbance term. This error term or disturbance term captures everything we didn't include in the model. Things like differences in soil quality, farmer experience, pest attack, rainfall variation, log, etc. Without this error term, the model will assume a perfect prediction. This model will assume a perfect prediction, but real life is never perfect. So that's why we add the random error. Now then, from mathematics, we now move to statistics. And this statistics helps us collect data from many irrigated farms, and then by collecting data we can be able to estimate the beta values as this beta values, and then when we estimate the beta values, we can now test whether the relationship between dependent variable and independent variable, the relationship is real, whether the relationship is significant or insignificant or highly significant or moderately significant. So everything you learn in this course is just these three working together. It's just these three working together. Now, the last part of this video is last part in this video is this: the reason why we study econometrics. Why do we study econometrics? Why do we study econometrics? So among the reasons why we study econometrics is 1, to make better policy decision. Yes, how? For example, government wants to know whether subsidizing irrigation pumps will really help increase rice production by 20% or by 5% only. That is what econometrics is all about. Econometrics gives the exact answer. Will subsidies on irrigation really increase rice production? And then if that is the case, if yes, then by how much percent? Is it 20%? Is it 5%? Econometrics, brings about this. Second, among the second reason is it helps farmers to maximize profits and then minimize costs. Yes. How? For example, You as an extension officer or agri-economics, you can tell farmers in your village that based on data from 300 irrigated rice farms, adding one more extra bag of fertilizer NPK gives you an extra 180 kilogram of rice. But after that bag, after that one, it is no longer necessary. That kind of advice comes from who? From econometricians, from those who study econometrics, or from those who specialize in econometrics in the Faculty of Agriculture, particularly in agri-economics. Thirdly, the reason why you study econometrics is to test economic theories with real Nigerian data. Many theories were made in America, in Europe, in Asia, in many continents. We use econometrics to test whether these theories are workable, are feasible, are doable here in Nigeria. It is only with econometrics that we test whether these theories are workable. If they are workable, then we borrow them and then apply them here and get our desired results. Thank you for watching. Subscribe to our channel, BAYO STEM Academy. And then the next video will be the explanation on parameters of econometrics like A constant, B, T, standard error, and particularly on irrigation. Next video will be on irrigation, regression. The next video is going to be on regression, and then possibly the third video will be on explanation of the regression outputs, R squared, standard error.